Force, energy and power, number 13. Unlucky for some. Now, this time we have a small lift in a hotel which is fully loaded and has a total mass of 250 kilograms. For safety reasons, the tension in the pulling cable must never be greater than 3,500 newtons. That's T max. And T max is quite simply when the cable snaps. So if the tension in the cable ever gets over 3,500 newtons, the cable snaps and everyone in the lift plunges to their doom. Hence, question number 13, unlucky for some. Part A, we're asked, what is the tension in the cable when the lift is at rest? Well, we're going to use that formula again, because the tension in the cable is going to have to be equal to the weight that's hanging from the cable. And that's going to be the mass multiplied by G to get the weight, and also by A to allow for any acceleration that's happening. So let's plug the numbers in. We've got 250 kilograms times 9.8 for gravity and an acceleration of 0, because in part A the lift is at rest, therefore it is not accelerating because it's not even moving, and that should give us 2,450 newtons. In part 2, moving upwards at a constant speed. Now this is the type of physics question where we actually are testing, did you read the question? Because it says moving upwards at a constant speed. If it's moving at a constant speed, the acceleration must be 0, which means it's going to be the same answer as I got for A part 1. Going to be the same answer for a different reason, but it's going to be the same number answer. So let's just cut to the chase and pop it in there. If you were doing this in an exam, I would still be looking for you to be writing down the equation and the working and the answer, because it's 1 mark for each. So don't throw away 2 marks by managing to forget to put in the 0 or something, or forgetting to put the N for units on the end, because even if you manage to do that but you've written everything else out, you're still picking up 2 of the 3 marks. In part 3, moving upwards with a constant acceleration. So part 3, it's moving upwards, the lift and all its passengers, with a constant acceleration of 2 meters per second squared. So let's break out the formula again. And what I'm doing by writing this bit is I'm telling anyone that's looking at this that I know the tension has got to be equal to the weight plus the gravity plus the acceleration. So I'm counting this has got to be equal to that. I could shorten it down like so if I really wanted to. So once again, 250 times 9.8, but this time plus 2, so that's going to give us 2,950 newtons. Like that. And for part 4, this is all part A, remember? So A part 4, this time it's going downwards with a constant acceleration of 2 meters per second squared. So this time it's going downwards at 2 meters per second squared. So I'm going to bung in a negative sign to allow for the direction. So tension is going to be mass times G plus A equals 250 times 9.8 minus 2. And that's going to give us 1,950 250 newtons. Now, this is where we need to use a little bit of real life thinking. Why is that a minus sign? Well, think about it. If you were, foolishly, standing at the top of the lift with the lift cable going through your hands, and you were allowing it, ignoring the fact that this would rip your fingers to pieces, you were allowing it to drop, allowing the lift to drop and the cable to go, would you be feeling much of a pull on the cable? As much as if you were holding it still, or as much as if you were pulling it upwards? Well, no, you'd be feeling less. So that logic means we must have a minus sign in there. Now, on to part B. Part B, calculate the maximum permitted upward acceleration of the fully loaded lift. Well, this is probably the easiest part of this question. The maximum acceleration is going to be A. We want the maximum acceleration, and the maximum acceleration will come when we've got the maximum tension, which was, according to the start of the question, 3,500 newtons. We haven't changed the mass, that's still 250. G was 9.8, and we want to know what A is. So we do a quick little bit of algebra, and that should end us up with 9.8 plus A equals 3,500 over 250. So A equals 3,500 over 250 minus 9.8. It should give us A equal to 4.2 meters per second squared. And that's that done. And then finally, part C. I'm going to put this here to save paper because it's such a silly answer. Well, it's not silly, but it's so simple and so straightforward. I hope nobody spent a lot of time trying to work this out. It'll be anything along the lines of when the lift is not fully loaded. Now, strictly speaking, the person who said, if the lift was in a hotel on Mars, is technically correct. But since nowhere in the question did it mention Mars, we assume that it's on Earth. And so you might not have picked up the marks for that one if you tried it in the exam.